Welcome to the Lsat Reading Comprehension lesson number 4. For today, we are going to make out main idea questions. Actually, main idea questions, as the name suggests, require you to pick the answer choice that most accurately states the main point of the passage as a whole. Almost every passage in the reading comprehension section includes a main idea question. The annotative reading strategy you learned in the previous case will help you answer these questions quickly and with a high rate of accuracy. Step first, read the question and identify your task. A main idea question will be worded in one of the following ways. Which of the following most accurately expresses the main point of the passage? Next, which of the following most accurately summarizes the main idea of the passage? And the last, the passage most helps to answer which one of the following questions. So, the highlight pointed expressions here is which of the following questions most accurately expresses or summarizes. Let's go to the second step. Second step, go back to the passage and find an answer. By creating a summary of the passage as part of your annotative reading process, you have done the hard work of finding an answer to a main idea question. That said, it's important to recognize that a summary is not the same thing as the main point. The main point of the passage is the core idea that it's trying to persuade you. The summary contains the main point, but it also contains background information and evidence or arguments offered in support of the main point. Third step, read every word of every answer choice. The right answer to a main idea question will be the portion of your summary of the passage that embodies the key takeaway from the passage. The right answer will usually borrow or quote some language directly from the passage itself. Since main idea questions ask you about a big picture concept, it can be tempting to go beyond what you have read and speculate about the passage's significance or implications. As you work through the answer choices, keep in mind that the correct answer must be objectively, demonstrably correct, based solely on the material in the passage. Now, let's go forward to the common types of wrong answers. Too broad in scope. This is the most common type of wrong answer on main idea questions. Several of the incorrect answer choices are likely to go beyond the scope of the passage. They might discuss new information about a related topic. They might make a comparison between the topic of the passage and an outside topic that was not discussed in the passage. In particular, keep an eye out for the word only, which simply makes the strongest possible comparative claim about the content of the passage. Second common mistake, too narrow in scope. At least one of the wrong answers to a main idea question is usually the main point of one paragraph. Such answer choices are designed to trick you, since they are focused on too small a portion of the passage. Third, in the right direction but too strong. Finally, some wrong answers to main idea questions will express an idea that is similar to the one expressed in the passage, but that is stated in overblown, amplified terms. The passages are excerpted from academic writing. They are cautious and precise. Watch out for answers that take the basic point of the passage and state it a little too categorically or forcefully. Now it's time to practice. We read, we mark, annotate the passage that will appear on the following page. We will write down the summary, then we will complete our reading passage with main points. We will circle it, highlight, and underline. Let's get started. So here is our reading passage, reading comprehension passage. Let's get started with the reading. To contain oil that has spilled into the ocean out of tanker ship or a drilling platform, petroleum engineers have traditionally utilized a two-pronged strategy of containment and dispersal. Dispersal is accomplished by some combination of chemical and biological agents, while containment has primarily been accomplished by deploying mechanical booms. Booms are temporary physical barriers that float on the water's surface. A portion of the barrier extends above the surface of the water. Most booms are made of a highly absorbent polypropylene material so that they will absorb some of the oil that is floating on the surface. The booms are also fitted with underwater skirts that extend anywhere from 18 inches to 4 feet below the surface. The skirts contain and capture oil that has become submerged. So here, main point started with while containment has primarily been accomplished by deployed mechanical booms. The next one, the next main point. Industrial engineers Field Neigert and Grom Ignas have recently developed a new technology that creates a curtain of air bubbles to contain an oceanic oil spill. The technology starts with large perforated rubber hoses, approximately 40 feet long by 5 feet wide, being attached to powerful air compressors and mounted on pieces of stainless steel or fiberglass grating. The hoses and grating are then submerged about 7 feet below the surface of the water. Air circulated by the compressors escapes into the water through the hoses' perforations. The escaped air creates a dense curtain of bubbles which immediately rises toward the surface. The bubbles carry the surrounding water with them as they rise. When that water reaches the surface, it creates a horizontal current. Since floating oil cannot cross the current serves to contain the spill. As the pressure of the air released by the compressor increases, the strength of the current created by the bubbles increases concomitantly. The stronger the horizontal current, the better it is able to contain the oil. Next, and the third main point here, the use of air bubble curtains to contain spills has distinct advantages over the use of mechanical booms. Mechanical booms can effectively contain spilled oil in ambient currents only up to 19.7 inches per second. Stronger currents cause oil drainage to seep under the bottom of the boom skirts, and increased surface choppiness associated with stronger currents can cause oil to wash over the tops of the booms. Air Bible curtains, Nygaard and Idness claim, are presently able to contain oil spills in ambient currents as high as 27.5 inches per second. In part because the bubbles helps to reduce the wave action on the surface. In theory, a denser curtain of bubbles could be effective in even stronger currents. But creating a denser curtain would require an amount of air to be forced out of perforated hoses that exceeds the present capabilities of commercially available compressor technology. Another advantage of air bubble curtains is that boats can travel across them on the surface of water, while the development of mechanical booms renders the water non-navigable. So here is the summary right now to show you the headlines of main points or main ideas, wherever. First is oil spills have historically been contained with mechanical booms. Second, but there is a new method that uses curtains of air bubbles to contain spills. And third, and this new method has advantages over the use of booms. So let's go to the practice question. Which of the following most accurately expresses the main point of the passage? A option. Despite its limitations, the use of air bubble curtains has proven to be more effective than any other method of containing oil spills. B option. Two industrial chemists have made a valuable contribution to the field of petroleum engineering with their development of air bubble curtains, a compressor-based technology for containing oceanic oil spills. C option. The use of air bubble curtains is a new method for containing oil spills that has distinct advantages over the use of mechanical booms. Mechanical booms, an unreliable method used to contain past oil spills, can finally be abandoned now that air bubble curtain technology has been developed. Most petroleum engineers today have rejected the use of mechanical booms and are embracing the use of air bubble curtains as the most effective method for containing oil spills. So let's analyze and answer to this question. Actually, it's very evident that the correct option here is C. The use of air bubble curtains is a new method for containing oil spills that has distinct advantages over the use of mechanical booms. So, actually, we need to analyze how is that? How choice C tracks sentences 2 and 3 of the summary of the passages and quotes language from the topic sentence of the third paragraph. Third paragraph here, and this new method has advantages over the use of boom. It's pretty evident from the first main point sentence of the third paragraph. Even on main idea questions, the answer is in the passage. You just have to find it from the first and even in the middle of the paragraph. So the use of air bubble curtains to contain spills has distinct advantages over the use of mechanical booms. Then, air bubble curtains, Nygaard and Iden's claim, are presently able to contain oil spills in ambient currents as high as 27.5 inches per second, in part because of the bubbles help to reduce the wave action on the surface. Choice C doesn't say much about paragraph 1, but that's okay. The purpose of paragraph 1 was to provide background information. So it's content that can be omitted from a statement of the passage's main point. That's the difference between a main point and a summary. Now, let's analyze choices A and E. Despite its limitations, the use of air bubble curtains has proven to be more effective than any other method of containing oil spills, and E option. Most petroleum engineers today have rejected the use of mechanical booms and are embracing the use of air bubble curtains as the most effective method for containing oil spills. So, they are wrong for the same reason. They go beyond the scope of the passage to compare air bubble curtains to all other spill containment technologies. The only other technology to which the passage compares air bubble curtains is mechanical booms. Choice B. Here, two industrial chemists have made a valuable contribution to the field of petroleum engineering with their development of air bubble curtains, a compressor-based technology for containing oceanic oil spills, accurately states the main point of paragraph 2nd, but it omits any discussion of the opinion expressed in paragraph 3rd. And at last, choice D, mechanical booms, an unreliable method used to contain past oil spills, can finally be abandoned now that air bubble curtain technology has been developed. This choice D takes the basic idea of the passage, which is that air bubble curtains have some advantages over mechanical booms, and states it too strongly. Nowhere does the passage say that booms are unreliable or should finally be abandoned. Next reading passage with the main points. A trademark is a symbol or designation that is used in commerce to identify and distinguish a particular person's goods from the goods manufactured or sold by other persons. The most common type of trademark is a brand name. Companies can also trademark logos, slogans, signs, and other physical manifestations of their brands. Trademark law also protects a company's trade dress, which is the overall appearance and image of the company's products. Trademarks provide an economically valuable function by making it easier for consumers to differentiate between brands of goods, quickly identify a preferred brand, and develop brand loyalty. The next main point and next paragraph is trademarks' ability to perform these functions can be eroded by the conduct of a holdover trademark licensee. A holdover licensee is a person who was previously licensed to use another person's trademarks and continues to use those marks without authorization after the expiration of his license. Large companies, especially in the restaurant industry, often sign franchise agreements under which the company licenses a franchise owner to use the company's trademarks and trade dress, including its name, logo, menu, floor plan, and decorative scheme. If the franchise agreement expires, the franchisee is no longer licensed to use the company's trademarks. But in this circumstance, many former franchisees continue to use some or all of the company's trademarks. Holdover licenses, continued use of the company's trademarks can cause substantial diminution in the value of the marks by associating them with different, sometimes inferior goods. A holdover licensee also profits from the goodwill associated with the trademark despite having neither helped create that goodwill nor paid for the right to capitalize on it. The following main point from new paragraph is unauthorized use of trademarks can violate federal law in either of two ways. The first is by committing trademark infringement, which occurs when the defendant uses a spurious trademark that is confusingly similar to a genuine trademark. Trademark infringement, such as attaching a deliberately misspelled Louis Vuitton label to a cheap handbag, creates a risk that consumers will mistakenly believe that the defendant's products were manufactured by the trademark owner. Trademark counterfeiting is a more serious form of trademark infringement. Counterfeiting occurs when the defendant makes unauthorized use of the owner's genuine trademark, such as by attaching a forged Louis Vuitton label to a cheap handbag. While trademark infringement can be accidental, trademark counterfeiting is almost always intentional. Trademark counterfeiting carries more severe penalties, such as high amounts of monetary damages and awards of attorneys' fees. And the last main points paragraph is it's apparent that holdover licenses are guilty of trademark counterfeiting, not merely of trademark infringement. The more serious penalty is appropriate because preventing consumer confusion is the primary policy goal of trademark law. The risk of consumer confusion is at an apex when a former licensee sells his or her own goods under the banner or a physically genuine, originally legitimate trademark. A trademark's value emanates from the connection it represents to a particular good. The holdover licensee's use of someone else's trademark to market a different good diminishes that value, thereby diluting the integrity of the brand represented by the mark. Now, let's go to our summary. First, main point is trademarks identify and distinguish particular brands of goods. Second, but holdover licenses unauthorized use of trademarks interferes with that function. Third, unauthorized use, infringement, or counterfeiting. And fourth, and holdover licenses are guilty of trademark counterfeiting. So, which one of the following is closest to the meaning of the word spurious as used in line 40? In authentic, accidental, alternative, clandestine, debatable. Let's go to our line 40 and analyze what is that. Maybe some suitable options we will find. So the first is by committing trademark infringement, which occurs when the defendant uses a spurious trademark that is confusingly similar to a genuine trademark. So let's analyze what is that. Returning to the passage and reviewing the three sentences from here. So we need to go forward. Trademark infringement, such as attaching a deliberately misspelled Louis Vuitton label to a cheap handbag, creates a risk that consumers will mistakenly believe that the defendant's products were manufactured by the trademark owner. And the last, trademark counterfeiting, is a more serious form of trademark infringement. So three sentences surrounding the word spurious in line 40 reveals that, in context, the passage is contrasting spurious trademarks with genuine trademarks. As the example of the deliberately misspelled Louis Vuitton label illustrates, you are looking for an answer choice that captures the idea that a spurious trademark is a knockoff or an imposter. So, therefore, the correct answer is choice A, in authentic. That's correct version. Next, our reading comprehension lesson and the passage. General circulation models are large-scale computer models used to simulate the Earth's climate so that climatologists can make predictions about how the climate will change in the future. The climate scientists who designed these models have struggled with the problem of predicting the effects of climate feedback changes to the natural environment, which are triggered by climate change and in return cause additional climate change. Permafrost carbon stores could be a significant climate feedback. Examining the potential positive feedback effect of these stores provides some insight into climate feedbacks generally. Climatologists now estimate that high-latitude permafrost, soil that consistently remains at or below 32 degrees Fahrenheit, contains approximately 1.5 trillion tons of frozen carbon. If the warming of the global climate were to cause the permafrost to thaw, that frozen carbon could be released into the atmosphere as carbon dioxide or as methane. This large-scale release of potent greenhouse gases could significantly accelerate the rate of global temperature rise, which in turn could cause faster melting of the permafrost, which in turn could cause the release of even more heat-trapping gases. Many climate scientists believe that the net effect of all global climate feedbacks, including those not yet discovered, is likely to be positive. However, Richard Linson's research team has concluded that most general circulation models actually overestimate the significance of positive feedback. Linson has identified several potential negative feedback effects that he predicts will dramatically slow, if not entirely prevent, an increase in average global temperatures. A warmer climate could produce a greater number of thick, low altitude rain clouds, the tops of which would deflect a higher percentage of the sun's radiation out of the lower atmosphere. Warmer temperatures near the equator could cause the rate at which the oceans absorb atmospheric carbon dioxide to accelerate. Trees also absorb carbon dioxide. A rise in global temperatures could cause trees to grow bigger, faster, and more densely, thereby increasing their carbon uptake. It's likely that an increase in global mean temperatures will produce some negative feedbacks that tend to mitigate the effects of that temperature increase. But it's also the case that Linson has likely overestimated the magnitude of these negative feedback effects. For example, while it is true that clouds reflect that heat back into space, they also trap heat that has been emitted from the surface. The complex balance between these two processes is unlikely to tilt heavily toward reflection. Additional heat trapping is all but inevitable. Temperature increases will also cause an increase in the intensity of equatorial winds, and oceans absorb less carbon dioxide in a windy environment. In addition, positive feedbacks are likely to undermine the operation of some of the negative feedbacks that Linson has identified. Warmer temperatures are associated with an increase in the frequency and severity of wildfires. Any carbon dioxide that was removed from the atmosphere by the faster growth of larger trees would be released into the air by a large scale forest fire. So that's the end. Let's go to our summary. First main point here, the climate scientists who designed GCMs struggled with how to predict the effects of climate feedbacks. Second, Linson's research team, most GCMs overestimate the significance of positive feedbacks. And the third main point, but Linson's research likely overestimated the magnitude of negative feedback effects. Question 1. According to the passage, greenhouse gases released by the thawing of the permafrost, A option, both reflect heat back into space and also trap heat that has been emitted from the surface. B option, could cause global temperatures to increase at a substantially faster rate. C option is one of the potentially significant negative climate feedbacks identified by Richard Linson's research team. D option would probably be in the form of methane rather than carbon dioxide. And the E option could cause an increase in the frequency and severity of wildfires. So let's analyze and answer to this question. Actually, the question asks about the thawing of the permafrost. The annotations show and demonstrate that this topic was discussed in the first paragraph. Here it is. After quickly reviewing the discussions at lines from 10th till 25th, permafrost carbon stores could be a significant climate feedback. Examining the potential positive feedback effect of these stores provides some insight into climate feedbacks generally. Climatologists now estimate that high latitude permafrost soil that consistently remains at or below 32 degrees Fahrenheit contains approximately 1.5 trillion tons of frozen carbon. If the warming of the global climate were to cause the permafrost to thaw, that frozen carbon could be released into the atmosphere as carbon dioxide or as methane. This large-scale release of potential greenhouse gases could significantly accelerate the rate of global temperature rise, which in turn could cause faster melting of the permafrost, which in turn could cause the release of even more heat-trapping gases. So you turn to your answer choices here. Okay. As for choice A, both reflect heat back into space and also trap heat that has been emitted from the surface. Nothing in the first paragraph talks about the reflecting and trapping of heat. This choice is taken from the discussion of clouds at lines 51 to 55. Here it is. That clouds reflect heat back into space, they also trap heat that has been emitted from the surface. The complex balance between these two processes is unlikely to tilt heavily toward reflection. Additional heat trapping is all but inevitable. Let's move to the choice B, could cause global temperatures to increase at a substantially faster rate. Looks good. It paraphrases the content contained in lines 17 till 23 of the passage. So, if the warming of the global climate were to cause the permafrost to thaw, that frozen carbon could be released into the atmosphere as carbon dioxide or as methane. This large-scale release of potent greenhouse gases could significantly accelerate the rate of global temperature rise, which in turn could cause faster melting of the permafrost. Choice C is one of the potentially significant negative climate feedbacks identified by Richard Linson's research team. Actually, this option contradicts lines 11 to 12. Here it is, examining the potential positive feedback effect of these stores provides some insight into climate fix feedbacks generally, which say that the permafrost carbon stores are a potential positive feedback. Additionally, the permafrost is not mentioned in paragraph second discussions of the findings made by Linson's research team. Let's move to the option D, would probably be in the form of methane rather than carbon dioxide. Choice D is a distortion of the statement at lines 19 till 20. Here it is, released into the atmosphere as carbon dioxide or as methane. So that is a distortion, that carbon released by the thawing of the permafrost would be either in the form of carbon dioxide or methane. The passage doesn't take a position on which of those gases would be more prevalent. E option could cause an increase in the frequency and severity of wildfires. Actually, choice E references the discussion of wildfires that appears at line 63 till 66. Any carbon dioxide that was removed from the atmosphere by the faster growth of larger trees would be released into the air by a large-scale forest fire. The passage states that warmer temperatures could cause more frequent and severe wildfires, and the passage also states that the thawing of the permafrost could cause warmer temperatures. It might seem reasonable to connect these two ideas, but the passage itself never makes that connection. Actually, here, choice B is closely and directly tethered into the passage contents. So it is the correct answer. B could cause global temperatures to increase at a substantially faster rate. That's the end of this lesson.